Welcome to episode 14 of The Explainer. Today we're tracing a really incredible philosophical quest, the architecture of digital contracts, going all the way from SGML to Szabo. We're going to explore how this wildly ambitious attempt to eliminate human error and ambiguity by formalizing digital text actually ended up paving the way for formalizing commerce itself.
So to kick things off, let me throw a question at you right out of the gate. What does a vending machine have in common with a lawyer? Now, other than occasionally eating your money and refusing to cooperate, the real answer here actually unlocks the complex, high-stakes world of legal automation that we're living in today. Just keep that question in the back of your mind for a second, because we'll get to the answer shortly.
All right, let's jump right into this. Our whole journey of formalization didn't actually start with commerce or the law at all. It started with computer scientists just trying to logically structure documents. Back in 1981, Charles Goldfarb introduced this generalized approach to document markup, which laid the foundation for SGML. And guys, this was a massive paradigm shift. It was a foundational attempt to make machines actually understand the structural intent of human text. So getting a computer to know that a line of text is officially a headline, rather than just a bunch of large, bold letters.
Goldfarb nailed down a super important distinction here. He completely separated descriptive markup from procedural markup. Descriptive markup tells the computer what a piece of text fundamentally is, like identifying a chunk of text as a title or a paragraph. Procedural markup, on the flip side, just gives a command about what the text should look like, instructing the computer to, say, center the text or make it bold. By making this split, early text formalization was trying to totally isolate a document's true semantic meaning from its physical presentation.
But, it's never just a simple toggle switch, right? Digital humanist Alan Raniere came along and proved this is actually deeply complex. He created this multi-dimensional taxonomy, showing that markup is really an intricate mix of grammatical mood, like is it indicative or imperative, and semantic domain, is it logical or renditional. Raniere basically revealed that text markup isn't just some dry technical indexing system. It's a highly sophisticated system of formal linguistic assertions.
So let's trace how this evolved. This formalization of structured text eventually gave us the World Wide Web through HTML and XML. But by the 1990s, thinkers realized something totally profound. If structured text could be formalized for universal data interchange, well, legal agreements could undergo that exact same transformation. We swoop from Goldfarb's SGML in 1981 straight to 1994 when the concept of the smart contract was born, and then eventually into the modern blockchain era with Bitcoin in 2008 and Ethereum in 2013, which actually deployed these concepts into the wild.
That 1994 milestone brings us to cryptographer and legal scholar Nick Szabo. He's the one who actually coined the term we use all the time today, defining a smart contract as a computerized transaction protocol that executes the terms of a contract. Szabo's revolutionary idea was to take the messy ambiguity of human commerce and translate it directly into self-enforcing programmed performance. The goal? Replacing human enforcement with a purely digital protocol. Which brings us right back to that opening hook about the vending machine and the lawyer. Szabo actually used the humble vending machine as his classic conceptual illustration for all this. Think about it. A vending machine is basically a proto-contract. You don't negotiate with it. You put your money in, the machine evaluates that the condition has been met, and boo, a soda comes out. It autonomously enforces a meeting of the minds without a human intermediary, which minimizes the need for trust and vastly reduces transaction costs.
Now, to scale that mechanical vending machine up to the digital age, Szabo outlined 4 primary design objectives for this whole architectural plan. First, transparency, so parties can observe the execution in real time. Second, verification, allowing for independent confirmation that obligations were actually met. Third, privacy, making sure control stays exclusively with the parties involved. And fourth, and this is absolutely crucial, enforceability. By embedding enforcement directly into the tech protocol itself, Szabo wanted to minimize our reliance on trusted third parties and literally, mathematically, reduce the potential for fraud.
The really amazing thing is how deeply he thought about this translation. Back in 2002, Szabo created a formal drafting language to specify contract terms, explicitly mapping ambiguous legal concepts straight into deterministic computer code. So a legal condition precedent becomes an event listener triggered by the keyword when, and a fuzzy legal deadline, where, a human judge might forgive you for being 5 minutes late because of traffic, becomes a rigid, totally unforgiving within period temporal bound.
You've really got to pay special attention to that with keyword, which introduces this concept known as the atomic swap. This is a purely formalist concept. In traditional law, ensuring a simultaneous mutual exchange happens fairly, like handing over the cash at the exact literal second you get the car keys, is notoriously difficult. But by translating this into a computational atomic transaction, the protocol ensures that the transaction either completely succeeds for both parties or, like magic, it entirely rolls back as if nothing ever happened at all. It mathematically eliminates the risk of a one-sided breach.
So how does this actually execute in practice? It's a brisk, highly deterministic three-step dance. Step 1. You encode a transparent, unilateral offer onto the network. This is often called a glass-box smart contract. Step 2. A user transfers an asset to meet that pre-programmed condition. Step 3. The contract autonomously and simultaneously releases the agreed-upon asset. That's it. Zero human intervention, immediate and unalterable.
But Szabo didn't just want this stuck in cyberspace. He envisioned bridging the gap between digital code and real-world physical compliance using these things he called proplets. These are smart physical control devices embedded directly into real-world assets. Imagine missing your car payment, and a proplet embedded right in the engine automatically revokes your ability to start the vehicle. It's literally a car that repossesses itself, automating enforcement without ever needing to call a judge or hire a repo team.
All of this creates this incredibly stark juxtaposition between wet code and dry code. Wet code is our traditional human language and traditional contracts. Wet code is inherently ambiguous, it's highly relational, and it's often very forgiving, mostly because we humans are forgiving. Dry code, on the other hand, the language of computers, operates strictly on Boolean logic. It's binary, it's deterministic, and it is entirely cold. It doesn't care if you had a bad day. If the condition isn't met, the code just does not execute.
Now, Szabo's theoretical concepts from 1994 were absolutely brilliant, but they needed an environment to actually live in, and that finally arrived with modern blockchain technology, notably Bitcoin and Ethereum. These decentralized, immutable ledgers gave us the exact infrastructure needed for autonomous execution without any central authority pulling the strings. This was really the ultimate elevation of technology itself acting as a regulatory mechanism. However, bringing this into the real world introduces a massive collision between two totally distinct universes. On one hand, you have the formalist dream of smart contracts, the absolute efficiency of autonomous, inflexible code executing exactly as it was written. But on the other hand, you have traditional jurisprudence, legal systems built entirely on prioritizing substance over technical form, relying heavily on human interpretation, and offering equitable flexibility when circumstances inevitably change. To see how traditional real-world law handles this kind of rigid code, you really just need to look at Canadian securities law, which boldly states, a security is what the law says it is. Now, that is not lazy drafting. Legislators intentionally use broad, open-texture definitions like that to maintain regulatory flexibility, because they know for a fact that if they create a strict, narrow checklist, clever actors are just going to structure their transactions to perfectly exploit those formalistic loopholes. And history shows us over and over that courts actively reject strict formalism to protect the public. Just look at the landmark 1978 Supreme Court of Canada decision in Pacific Coast Coin. The court actually expanded existing tests so they could focus strictly on the economic reality of the arrangement, completely ignoring whatever private labels the parties tried to slap on it. Courts prioritize substance to prevent regulatory arbitrage. Basically, they're stopping clever coders from finding technical loopholes to bypass the law, ensuring the protective purposes of the law are actually met, regardless of the clever technical structuring. We see this exact same thing sustained today in decisions like R.V. Stevenson. That case dismantled attempts to construct legal definitions, proving that courts will look completely past the code and the form of a contract. They evaluate the actual economic expectations of the participants involved. It's a resounding signal that human law has to remain adaptable, prioritizing economic function over technical structure to protect normal people in everyday transactions, whether they're investing or buying property.
Which leaves us here. We've traced this incredible path from formatting text in the 80s to programming self-executing commerce today, proving that yes, we can translate human intention into deterministic binary logic. But as we blend these two worlds, we have to ask a pretty profound question. Is the ambiguity of human language a bug that must be eradicated by perfect code? Or is that very messiness the vital, forgiving feature that actually keeps our society functioning? Thanks so much for joining me on this explainer. I'm going to leave you to chew on that one.